Welcome all of you to Annie Maths. This is my second video on polynomials, 9th standard. Okay, so in this topic, in this video, we shall be taking up polynomials, that is 0 of a polynomial. Okay, how to find 0 of a particular polynomial, that is what sums based on that we are going to take up today. Okay, and also a particular value of a polynomial when the value of x is given, sums of this type we shall be taking up today in today's video. So always I've been telling you all this polynomials chapter will be completed in about 4 videos. It will take 4 parts for me to complete it. So the part 1 we have done introducing polynomials. Second part we are going to do zeros of a polynomial, which is this video. Third part we are going to take up remainder theorem, and the fourth part we are going to take up factor theorem. So all my videos will be named as part 1, part 2, part 3 and part 4 of polynomials. And please, it is my request to all of you to please see the videos sequentially to get a better idea of the chapter. Okay, even if you are having doubts in a particular part of remainder and factor theorem, I would still suggest that you should see zeros of a polynomial and you should also see degree of a polynomial and then proceed to remainder factor theorem. Okay, so let's see what it is. So let's see what is 0 of a polynomial. Now sometimes we see some questions in this chapter written like this: px is equal to 2x square. Because I don't want you all to learn this chapter without understanding this. This is very basic. This kind of a question is given, and you don't understand head or tail of what is this. What is px suddenly? Till the last chapter there was no px, and now there's a px over here. So you don't understand what is that. This px is nothing but a function of x. Now function of x is a very big thing. I don't want to expand on it over here. But then basically it is representing this polynomial. Okay, it is only representing this polynomial, and this x is written here because this entire polynomial is written with the variable x. It's as simple as that. Okay, now the next thing is, if supposing I have 3y square plus 7y plus 7, something like that, then I would have written this. This is a function of y. Okay, this is a function of y. Okay, now as I said, this is just a representation of this polynomial. Now supposing I put here p, they are asking me find py for y is equal to 2, or even they can just say find p2 and they give you this equation. Okay, don't confuse with this. Okay, so they just give you this equation. I'll erase this one. So there's just one polynomial given and they ask you find p2. Then what do you do? Very simply, all you have to do is p2 is equal to 3 into y. In place of y, put a 2, 2 square plus 7 into 2 plus 7. Okay, what have I done? Everywhere, wherever there was a y, I have substituted a 2. So here you can see in place of y 2 square, in place of y 2. That is 3 with a 4 plus 14 plus 7. Okay. So plus 7. Then it becomes 12 plus 14 plus 7. How much? There is a 26 plus 7. Okay. 26 plus 7 is, okay, that's a 33. Okay, so that is a 33. So if you have p2, you are supposed to just substitute the value of 2 in all the variables because 2 has come in place of y. Now if they write find p3, substitute 3. They can even say find p minus 3, and you have to keep on substituting minus 3 everywhere wherever there is a y. Okay, so let's see. Now here is a question qy which is equal to, this is 3y to the power 4, 3y to the power 4, and then minus 5y cube plus y square plus 8. Yeah, this is my expression. This is my polynomial. Now they are asking find q minus 1. Okay, you'll get questions like this all the time in the question paper. Find q minus 1. What to do? So q minus 1 is equal to 3. Put a minus 1 everywhere. Minus 5 minus 1 cube plus minus 1 square plus 8. 3, 1 to the power 4 and minus 4 times is a 1. So I can just write a 3 here because it is 3 into 1. Minus 5, and this is gives me a minus 1. Minus 1 into minus 1 into minus 1 is a minus 1. Plus, this is a 1 now. Minus into minus is a plus. 1 into 1 is a 1. Plus 8. Okay. So that gives me this. Okay. So this is 16 and 17. Okay. So this is the value of this is a 17. That is q minus 1 is a 17. Likewise, they can set other questions also with positive as well as negative values. Now, sometimes just to confuse, just to test your understanding, just to test your concept, they can even ask q and a minus a. What you do? Everywhere, wherever there is a y, put a minus a. Okay, and it becomes like this: 3 minus a, and your final answer is an a only because you don't know the actual value of a. So you have to leave your final answer in a. Okay, so this is 4 minus 5 minus a cube plus minus a square plus 8. Yes, that is minus goes away because of the even power. So 3a to the power 4. This is minus a cube because the power is odd, the minus remains, plus 5 minus into minus plus a cube. Okay, then this becomes a plus a square plus 8. Now you can't move beyond this in this sum. You can't move beyond this. Why? Because you don't know the value of a. If they give a particular value a, different matter. But otherwise, if they just say q minus a, your sum ends here. This is the confusion. You keep wondering, how do I find the value of a? I don't know the value of a. But then you are not even supposed to know the value of a. You are just supposed to substitute and leave the question at this point. Okay. Now, let us see what is 0 of a polynomial. Okay. Now, find the 0 of a polynomial. Find the 0 of, okay, and they have given us the polynomial px is equal to x plus 3, something like this. What is the 0? Now, what is the meaning of 0 of a polynomial? Rather than the method, let us first understand what exactly they want by 0 of a polynomial. What is 0? This is basically 0 of a polynomial is that number which, if substituted in place of x, makes the value of this expression or this polynomial a 0. We are looking for that value of x that can make this expression a 0. This is a very simple one because it's the first question, but actually the polynomials can be very big, and everywhere, wherever there is an x, if we substitute one value, okay, then that value in x, if we substitute a value, the entire polynomial should be converted to a 0, should give a value 0. Okay, now it's not a very good thing, and it's not a correct method also to do it by hit and trial method. By trial and error, we put a 2 here, okay, not working, put a minus 3, okay, let's see if it works. That is not the correct way of doing a sum. So what we do is, first itself, we equate it to 0. X plus 3 is a 0, means anyways 0, the 0 of the polynomial, the value of x should have converted it to 0 only. So why not first write it as a 0, and according to this equation find the value of x. Means we are doing the same thing in a reverse order, because we don't want to use the trial method. It's not a correct method. You won't be getting marks even if you get your sum right. So here this forms a linear equation. So x is equal to minus 3. Now you can see for yourself, x is equal to minus 3 if you substitute here. Okay, x is equal to minus 3 if you substitute here. Okay, then you get the value of this much part is a 0. Okay. So, if x is equal to minus 3 is substituted here, the value becomes a 0. Therefore, 0 of this polynomial is equal to of px is equal to minus 3. Okay. So, the answer is minus 3. Let's take up another one. Qx, again they want us to find the 0, is equal to 3x plus 2. Okay, Qx is equal to 3x plus 2. Again, what we'll do? Because they are asking for that value of x, which when substituted here will make this whole thing 0. Now, if you substitute minus 3 here, clearly you can see that this part turns into a 0. So, here again a linear equation. So, 3x is equal to minus 2. X is equal to minus 2 by 3. Now remember one thing, this can have fractional values as well. So I'll just substitute it here, this value here, and show you how it gets converted to 0. 3x plus 2. Okay, in place of this, in place of the x, I have substituted this value plus 2. Okay, see, minus 2 plus 2, 0. So this is the 0 of qx is equal to minus 2 by 3. Yes, 0 of qx is equal to minus 2 by 3. Understand? Let us now come to a sum, which is verify. The question comes like this: verify if, okay, verify if 4 is a 0 of the polynomial, 4 is a 0 of the polynomial. What is the polynomial? Px is x minus 4. So it is the same question written in a different way. Okay. So we have to verify. What do we do? Now since they have given us a value of 0, we substitute it in x minus 4. So x minus 4, which is equal to, now after you substitute, 4 minus 4, and that is equal to 0. Definitely 4 is a 0 of this particular polynomial. Okay. Another one, verify if minus 3 is a 0 of the polynomial px is equal to px is equal to x minus 3. Okay, minus 3 is the 0 of the polynomial px is equal to x minus 3. What do I do now? Here, if I substitute minus 3 over here, it comes to minus 6. So I cannot say that minus 3 is a 0 of the polynomial, because it has not converted this polynomial to a 0, rather it gave me a value of minus 6. Okay. Another question, half is a 0 of the polynomial, 0 of which polynomial? It is py is equal to 2y plus 1. Yes. So now we'll have to verify this. Let's see. So if I put 2 into half, because they have given us half, so in place of y I'll put a half plus 1. See, is it coming to a 0? Definitely not. Okay. So half is not a 0 of this polynomial. Let us now make a small change in this question only. Let me put a minus. Okay. And then I'll put a minus here. Okay, what I'll get here is, here what I'll get, minus 1 plus 1, that's a 0. Yeah. Okay, so this is py is equal to 0. Then minus half is definitely a 0 of this polynomial, but we just saw that half is not a 0 of this polynomial. Then another question, verify if 1 and 2 are zeros of the polynomial, are zeros of, so now remember one thing, a polynomial can even have 2 zeros, it can even have 3 zeros. Okay, so basically there can be 2 numbers which convert that polynomial to 0, not just one. So 1 and 2 are the zeros of the polynomial px is equal to x minus 1, and this is how they have given the polynomial. This has been given in a little different way. Okay, so is 1 and 2 a 0 of this polynomial? Okay, now what do we do? Here, first let us put a 1. Okay, if we put a 1, we'll have to write it here as a p1. Don't just put a 1, because here you have, here I didn't have more than 1 0, but here I have 2 zeros. So let us put p1, means I'm going to substitute 1 now, and that is 1 minus 1, 1 minus 2, whatever the value is of this, I am not bothered. This itself is 0. 0 into minus 1, that's a 0. So definitely 1 is a 0 of the polynomial. Okay, now let me work out the second part also. The second part is p2, and p2 is 2 minus 1, that is in place of x I put the 2. 2 minus 1 and 2 minus 2. Now see, this is a 1, but this has become a 0. Again it's a 0. 1 into some 0 is a 0. So even both of them are zeros of this polynomial. Okay. Here is one last question of this topic. The question is like this: 2 and minus 3. 2 and minus 3. Okay, you will have to show whether 2 and minus 3 are zeros of this polynomial. Are zeros of which polynomial? Px is equal to, now this polynomial is slightly different, watch, x square plus x minus 6. Yeah, so this is slightly different. Now one thing, so here now if I put p2, 4, 2 square plus 2 minus 6, 4 plus 2, 6 minus 6, 0. Okay, now let us check the second part, p minus 3. This is minus 3 square plus minus 3 minus 6. This is 9. Okay, minus 3 minus 6, which is 9 minus 9, which is a 0. Okay, so 9 minus 9 is a 0. So clearly even this one is a, even this one is a 0 of this polynomial, as the final answer we have got it as a 0. Okay, so this is it for today. So that was 0 of a polynomial, and if you are still finding some tougher questions on zeros of a polynomial, you can post them in the comment section. Okay, so in the next video we shall be taking up more on polynomials. That will be part 3, and in part 3 we shall be taking up a very important part of polynomials, that is remainder theorem. So the entire part of polynomials will be done in about 4 videos, and then we shall be doing factor theorem, so remainder and factor theorem. So all the links of all the different parts of polynomials will be given in the description box. You can click there and see for a very clear concept. Okay, so if you have liked the video, do not forget to like, share and subscribe. See you then in the next video. Bye all of you.